Hello class, today we're going to be starting credit 2 of Geometry B. Credit 2 talks about similarities, so we're going to actually look at the properties of all the similarities. The first lesson that we're going to cover in this video is lesson 11.1, which talks about dilations. And the learning goal for this lesson is that if we're given a center and scale factor, can we verify that a figure has been dilated? So let's actually start this lesson on page 7. No, I'm sorry, page 6. So there's a couple of terms that we need to know before we start. The first one is, what is a dilation? A dilation is a transformation that can change the size of a polygon but leaves the shape unchanged. So a dilation changes the size, either makes an object bigger or smaller. And the thing that makes that object bigger or smaller is something called the scale factor. So a scale factor is a multiplier that could either increase the size of the image or decrease the size of the image. And just in general, in this example that they have right here, they show that you have an actual car here, a Ford, and then you have models of the Ford. Notice that you have 3 different types of models, but all of these models resemble the actual size or the actual dimensions of the actual car. One of the models is 24 times smaller, the other one is 32 times smaller, and the other one is 87 times smaller than the actual size. But all of these form the same kind of shape of the car. And that's kind of what we're talking about here. We're going to actually start with different types of polygons, like triangles, rectangles, and just other types of polygons, and just look at the properties of dilation. Okay, so let's talk about the properties of dilations. The 4 key things that we gotta understand is that dilations preserve angle measure, betweenness, collinearity, and orientation. So let's start with angle measure. The angle measure is the angle measured between 3 points. So we have angle A right here, and then angle A prime, angle B, and angle B prime, and angle C, and angle C prime. So for these 2 figures to be dilations, these angle measurements have to be equal to each other. And these have to be equal, and these have to be equal. If there's any change in any angle measure, the 2 figures are not considered to be dilated. The next thing is that dilations preserve the betweenness. Now, what the betweenness means is, if you look at this triangle, you have triangle ABC, and if you look at this one, you have A prime, B prime, C prime. So you don't see any change in the points, so you don't see ACB and then ABC, and that's what betweenness means. The betweenness means that the points are in line for each figure, so ABC, ABC. The next thing is collinearity, and what collinearity means is that 2 points form a straight line, 2 points on a straight line. So AB, that's on a straight line, BC, that's on a straight line, and AC, that's on a straight line. And it's the same here, AB, BC, and AC. The next one is orientation. So the orientation of these 2 figures remain the same. We don't see any other types of transformations like a rotation or reflection. These are the same bases, AC, AC. This is the right side, BC, BC, and this is the other side, AB and AB. So as long as we have each one of these checked off, that means that these 2 figures would be dilated. Okay, next let's talk about a scale factor. Um, in the beginning of this lesson, we talked about that a figure that is dilated could either be the size could either get smaller or it could get bigger, and that depends on the scale factor. So the first thing let's talk about is what makes an object become a bigger object, and that is if the scale factor is greater than 1. So these are examples, these are scale factors, and notice that each of these numbers are greater than 1. 3, 1.5, 24, 3 halves, and 5 thirds. Notice that these last two are improper fractions, and improper fractions are greater than 1. So if you have a scale factor that is greater than 1, the object is going to go, it's going to get larger. So then for an object to get smaller, the scale factor has to be between 0 and 1. Now when I say between 0 and 1, that means a number that is a fraction between 0 and 1. So these are examples: 1/4, 1/3, 0.5, 1/2, 2/3. So these are all regular fractions. These are all between 0 and 1, and this would make the object get smaller. Okay, so now we're going to actually do some examples. So in this example, they want us to determine if the transformation on the coordinate plane is a dilation. If it is, give the scale factor. So, like we said about the properties of dilation, we have to cover these 4 criteria, and then if we get yeses on each one, then we know this is a dilation, and then we could find the scale factor. But if one of these do not work, we don't need to worry about the scale factor because these two are not dilated. But let's look at each one. So the first thing is that these two figures, so that we have the pre-image and the image, they preserve angle measure. Now if we look at these, we look at angle A and angle A prime, it does seem like they do preserve the angle measure. All of these angles do preserve, so that's a yes. Do they preserve the betweenness? We look at that again. So we have A, B, C, D, and then we also have A prime, B prime, C prime, D prime. So the betweenness between the points is also a yes. The collinearity. So are the points on a straight line? So we have AB, that's a straight line, BC, CD, and then DA, and same here, AB, BC, CD, and DA, and that's a yes. Next, the orientation. So the orientation of this figure is facing this way, and we look at the orientation of this figure, it's facing the other way. So actually this would be a no. These two figures do not preserve orientation because this looks like a reflection of the original one. So that's a no. If we compare these two, these actually are the same size, because if we look at the length of the bottom, 1, 2, 3, 4, and the length of this bottom, 1, 2, 3, 4. These actually have the same scale factor, 1 to 1. But then the question is this transformation a dilation? And the correct answer is no, mainly because the orientation was not preserved. So that's what you're gonna be looking at, these 4 criteria when you're doing a problem, and just determining if you meet each one. Okay, let's do one more example. So our pre-image is ABC, and our image is A prime, B prime, C prime. So let's look at the preserved angle measure. Now, angle A and angle A prime and all of these angles look like they preserve the angle measure, so that would be a yes. The betweenness is also a yes because you have ABC, ABC. Collinearity, these points are on a straight line. All of these are on a straight line, so that's a yes. And then the orientation. So look at how this object is orientated. This object is facing this way and this object is facing this way. They actually have the same orientation. Next, scale factor. So how do we find the scale factor? What we could do is we could pick a point on the pre-image and on the image. So let me pick a point C. Point C is located at 0, 2. Sorry, this is supposed to be point C. Okay. And then let's look at C prime. C prime is located at 0, 4. Comparing these two, we went from 2 to 4. And the only way to get from 2 to 4 with multiplication is if we multiply by 2. So this is our scale factor, 2. And they actually have it right here. Scale factor is 2. And then yes, this does preserve, or this does form a dilation. So next, I want you guys to pause the video and work on the next two problems on your own, and then press play to see the correct solutions. So for number 1, we're doing the same thing. So determine if the transformation on the coordinate plane is a dilation, and then determine what the scale factor is. So we're going to start with, does this preserve the angle measures? So we look at the angle measures AA, BB, CC, yes. So I'm going to put a yes. Does it preserve the betweenness? A, B, C, D, E, A, B, C, D, E, yes. Does it preserve the collinearity? So all of these points are on a straight line, and all of these points are on a straight line. That's a yes. And then does it preserve the orientation? So yes, that does. Looking at the pre-image and the image, they're all facing the same direction. That's a yes. And then determine what the scale factor is. So we could look actually at one side. Now, if we look at this side here, DE, the length of DE is 1, 2, 3. So I'm just going to write right here, DE equals 3. What is D prime E prime? So that is 1, 2, 3, 4. Let me see. 1, 2, 3, 4. It looks like it's 4.5. To find the scale factor, what we're going to be doing is we're going to, let me write it right here. We're going to divide or find the ratio of the image over the pre-image. So 4.5 over 3, and that is equal to 1.5. So the scale factor is 1.5. Okay. Next, is this transformation a dilation? So you would put yes. Okay, and then problem number 2. So we have the pre-image A, B, C, and then A prime, B prime, C prime. Now, looking at these two, do they have the same angle measures? So we have this one, this triangle looks steeper than this triangle. So I would say no, they don't have the same angle measure. Do they have the same betweenness? They do, because it has ABC, ABC. Do they preserve collinearity? Yes, they do, because they're all in a straight line. Is the orientation preserved? It is not. What is the scale factor? So we're actually not going to worry about the scale factor because of these two no's. We know this transformation is not a dilation. Okay, next. Square A is the dilation of square B. What does the scale factor show your thinking? So when they're telling us that square A is a dilation of square B, they're telling us that B is the pre-image and A is the image. So we're going from the pre-image to the image. Now, we also know this is a square, and one property of squares is that the length of the sides are all equal. So if this is 35, this is 35, 35, 35. Then same thing for square B. This is 28, 28, 28. And then let's pick a side. So we're gonna let's pick this bottom side. So 28, and then we have 35. So how do we find the scale factor? So let me do that right here. The scale factor is the ratio of the image divided by the pre-image. So if the image is 28, if the image is 35, and the pre-image is 28, we have 35 over 28. Then what we have to do is we have to reduce this fraction to the lowest terms. And I see that 7 is a factor of 35 and 28. So I could divide both sides by 7. And I get 5 over 4. So that would be C. Now let's actually look at our answer, and does this answer does it make any sense? 5 over 4 is an improper fraction, and this fraction is greater than 1. And remember that if you have a scale factor greater than 1, your image is going to get larger, and that's what's occurring here. So we have square B is smaller than square A. When we multiply square B by this scale factor, it increases the size. So this does make sense. This is the correct answer, 5 over 4. Okay, next what we're going to be talking about is determining the center and scale of a dilation. So let me kind of read some things of this section. When you have a figure and its image after dilation, you can find the center of dilation. By drawing lines that connect corresponding vertices, these lines will intersect at the center of dilation. So with dilations, there's something called the center of dilation. And to find the center of dilation, I'm going to kind of show you in this figure here. Let's start with A. So let's say this is our pre-image, A, B, C, and this is our image, A prime, B prime, C prime. Notice you have point A here and point A prime here. And if you connect these two points and you draw a straight line all the way across, we have this line, and we do that if we do the same thing for C and B, we notice something here, that all points of those lines intersect here. This is called the center of dilation. Okay. Okay, next we're going to use a method to determine if a figure has been dilated on a coordinate plane, and there are two steps. The first step to see if a figure is dilated is to look at the slope of each side to determine the angle measure and orientation is preserved. So because we're not actually measuring the angle measure of each triangle, we're using the slope, and if the slopes are equal in the pre-image and the image of a side, that tells us that the angle measure and the orientation is also preserved. Okay, so remember from Algebra 1, to find the slope, let me see if I can write it right here. The slope is equal to the rise over the run. So let me start with, let's start with PQ. We have point P here, point Q here. To get from point P to Q, we have to rise 2, run 1. So that's why they have 2 over 1. Let's look at QR. So to get from Q, actually let's say, to get from R to Q, we rise 0, we don't go up, and we go over 4. So 0 over 4. To get RP, we're here. We start with R. We always start with the point to the left and go to the point to the right. So we go down 2 and then over 3. So we get negative 2 over 3. And then we do the same thing for the image points or the image sides. Let's look at one, P prime, Q prime, this one, this one. Notice that we go, to get from P prime to Q prime, we go up 6 and then over 3. So we have 6 over 3. But that actually reduces to 2 over 1. So these two are equal. They have the same slope. So the angle measurements and the orientations are preserved. After you check to see if the slopes are equivalent, then we could go to step 2 and identify the scale factor. So let's look at the length of QR. The length of QR is 4. The length of Q prime R prime is 12. What is the multiplier to get from 4 to 12? So 4 times what number is equal to 12? And that is 3. So this is the scale factor. Okay, so then I want you guys to pause the video here, and I want you guys to look at the next 2 problems. So it says determine the scale factor that dilated the pre-image to its image. So they're actually telling us here that these are dilations. So we don't actually have to figure out the slopes for these problems because they're actually already telling us that these 2 figures are dilated. But what we do have to find is we have to find the scale factor. Now to find the scale factor, I would pick a side that is straight. And I would count the squares to find the length of a side. So for number 1, let me pick AD and then I'll look at EH. So let me write this right here. AD is equal to 1, 2, 3. EH is equal to 1, 2, 3, 4. And remember, to find the scale factor, we do the image divided by the pre-image. So the scale factor would be 4 over 3. Next, for problem number 2, let's pick 2 sides that are straight. So if I look at the pre-image, This is the pre-image FG, and this is the image F prime G prime. Remember that the image always has that prime, and the pre-image doesn't have anything on top. So we're going from FG. What is the length of FG? That is 1, 2, 3, 4, 5, 6, 7, 8, 9. To F prime G prime. 1, 2, 3. So my scale factor would be 3 over 9 because the image divided by the pre-image, but then this reduces. I divide the top and bottom by 3, I get 1 over 3. So that is your scale factor. Okay, so that pretty much completes lesson 11.1. So let's kind of look at some of these homework problems, and let's let me see. For problem number 1 and 2, you're just looking to see which scale factor would give you a bigger image. So I think you guys could do that one. But let me look at. Let's look at problem number 6. Because that one looks a little bit different. Let me zoom into that one. So we already know that these two figures are dilations. So we have the pre-image. Let me see. We have HIJK, and then the image is H prime, I prime, J prime, K prime. Okay. So then, what we want to do to find the scale factor is we want to find a side that is straight. But if we look at the sides of these, none of these sides are straight. So an alternative is to look at the points and determine what the scale factor of those points are. So let me start by looking at point I. So this point right here. This point is located at 0, comma, so let me count 1, 2, 3, 4. So 0, 4. And then let me look at I prime. I prime is located at 0, 1. So we're going from a bigger image to a smaller image. So we know our scale factor is going to be between 0 and 1. It's going to be a fraction. But now, how do we get from 4 to 1 using multiplication? Well, let me do this on the side here. You know that 4 divided by 4 is equal to 1. But if you want to use this as multiplication, we could also say 4 times 1 over 4 is equal to 1. So dividing by 4 and multiplying by 1 over 4 are the same thing, and this is going to be our scale factor. So K, which stands for scale factor, is equal to 1 over 4. Okay, and then I do want to mention, let me see, on the checkpoint, what you're going to be doing is you're going to be plotting the points that they give you, and then use this scale factor to find the new points. All right, guys, well, have a good day.